sheet, the first thing you see is the sum of the interior angles. All right, the sum of the interior angles. So your formula here is you take, first of all, just the sum. Just the sum for that first part, you're going to take n minus 2, the number of angles, and multiply by 180. That is going to be your total sum, total. If they want one interior angle, and I'm just going to write 1, then you divide that number by how many sides you have. So if you want the sum of the interior angles, what do all of them add up to, which is the first set of questions you have there, you're going to take your number of sides, in this case, this one would be 5, subtract 2, and then multiply by 180, and that is your answer. All right, that would be your answer, which would be, for this guy, 540. The next set says it wants one interior angle. One interior angle. So if I wanted to know what just one of these angles equals by itself, I would then take that, the 540, and I would divide by my number of sides. All right? And so if I wanted to know what one angle is, I would divide by the number of sides. So your first set of problems is just the total, and the second set of problems would be divide. Now, on your quiz, I could say, find the sum of the interior angles, then find one of the interior angles measure, okay? So it could be combined on your quiz and ask for both parts, where you would have potentially two answers, all right? But if it wants the sum of the angles, you're going to do n minus 2 times 180. If it wants one of the interior angles, you're going to take that sum and divide by how many angles you have, or how many sides you have. That is the same. And so we've talked about this many times. Just if it's a parallelogram, and it will tell you this is a parallelogram, then find this information, all right? So for parallelograms, your opposite sides are congruent. They're equal in length. Your opposite angles are congruent. Your opposite angles are congruent. Opposite sides are parallel. So you can create some alternate interior angles because you have parallel lines. Consecutive angles are supplementary. They add up to 180. All right, so consecutive angles add up to 180. And then the diagonals bisect each other. So they cut each other in half. All right, so each piece of the diagonal, this piece and that piece will be congruent, that piece and this piece will be congruent. That's just a parallelogram. So that means that holds true for just the parallelograms and the rectangles and the rhombus and the square. All right, so all of that will hold true for the rest of them. From parallelograms, we moved into rectangles. So special parallelograms. So they have the same rules. Opposite sides are equal, opposite sides are parallel. All angles add up to 90. Okay, so all angles add up to 90. So every single angle is going to be 90. And my diagonals are not only bisect each other, they are also equal. They're also equal, which means every single piece of these are congruent, no matter which diagonal you are on. So for a rectangle, you add in the fact that you have 90-degree angles, that your diagonals are also congruent. All right? Rhombus. So rhombus has all the sides, all the things for a parallelogram. Sides are equal, opposite sides are parallel. Opposite angles are equal, supplementary angles for consecutive, etc. Diagonals, in this case, are perpendicular bisectors, and it says equal. They are not equal. Why that says equal? Your diagonals do bisect, right? They bisect each other, but they bisect specifically at a 90-degree angle, all right? So diagonals do bisect each other. They do bisect each other, but specifically they bisect at 90 degrees. So with something like this and with your rectangles, you could potentially use your Pythagorean theorem, right, to find a specific side length that it's asking for. So when you see a rectangle, a square, or a rhombus, in certain situations you may use your Pythagorean theorem because you've created this right triangle here when you have a rhombus on the inside. And on rectangles and squares, you have, actually for squares you have multiple, but for a rectangle, all of your corners are right triangles. So you could use your Pythagorean theorem there as far as finding diagonals or side length. And then your square takes on the characteristics of all of the above. So all the sides are equal, opposite sides are parallel, all your angles are 90 degrees. Your diagonals are not only equal, but they are also perpendicular bisectors. All right, so here the diagonals bisect each other at 90 degrees. They're also equal, just like your rectangle. So your square is one of the easiest ones when you start solving. When you get to that square page, you're going to see you have 90, 45 degrees, and then you have all sides are congruent. So you may use the Pythagorean theorem here as well.